Okay guys, now I want to explain the little diagrams or the bar charts. Okay, first you have to draw the L, 1L and O and L. In the first L, you will write your initial energy. This means energy, thermal energy. This one's means interaction energy, and this one's is the chemical energy. But we're not using the chemical energy because we don't need it because it doesn't change. So we will use the thermal energy and the interaction energy. Okay, so the first cell you will write your initials. What happened first with the coffee, because we're gonna talk about coffee. We're gonna have to draw bar energy, an energy bar, the chart for a cup of hot coffee that cools, and we have to show how many energy it leaves the system and stuff. Okay, first you already know that it's thermal energy and interaction energy, but in this case you have to start with the coffee temperature. So the coffee is hot right now, so we're gonna draw 4 bars for the hot coffee. One, two, three. Okay, we have 1, 2, 3, 4 bars. We draw 4 bars because the coffee is very hot, and now we have to draw in the interactional energy the 2 bars. We have only 2 bars because the coffee is liquid, and for solids you have to put 1 bar in interaction. In liquid you have to put 2 bars, and in gases 4 bars. That's the always like if we're talking about an ice cube, you have to only to put 1 bar because it's a solid. But as coffee is liquid, you have to put 2 bars. Then after you have the 2 bars, then you have to show if the coffee was very hot and you'll leave it in the table and it gets cooler, how many bars go away from the system for it to cool. So I will put the 2 bars. I will draw 1 bar here, 1 bar here. Get out of the system and leave only 2 bars of thermal energy. So now the coffee is not that hot, it's like more cool, and the interactional energy doesn't change, it keeps the same. 1, 2, so it keeps 2 bars. Here we have now 2 bars because the coffee is now more cool. So this will be our final coffee temperature.